To continue converting our interpreter to object-oriented style, we could take the Expr data type next. It has these variants, and the one operation on an Expr is to interpret. And you can see inside of interp we have this dispatch on the different cases. So that means that we're going to change our Expr. We're going to get rid of the data type and instead say that the type Expr, define type alias. The type Expr is going to mean a function because an Expr is going to be an object. And the operation on an Expr is interp, which takes an environment along with the expression and gives us back a value. That means that we need to redefine numc to be a function that takes a number, just like numc always did, and gives back an Expr just like numc always did, but now an Expr is a function that takes an environment as its object, as its argument, and returns a value. When you interpret numc in a given environment, then we don't actually have to look at the environment, we just return a numv. That would take care of the numc case. For the idc case, it takes a symbol s, which is the identifier, and returns an Expr, where an Expr is an object represented by a function that takes an environment and returns a value. An IDC does use the environment. We have to look up in the environment s. Though we don't have to call the lookup function anymore. Environment is an object, and so we could just call environment with the symbol s. Plus c is a constructor that takes two other Expr, left and right, and gives us a new Expr. The new thing is an Expr, which is a function that takes an environment. This function implements interp for plus c, and so it returns a value. And the way we interpret a plus c, recall, is that we interp the left in the environment, and we interp the right in the environment. But now our left and right, those are objects, and we call the interp on the object by just applying the object to an environment. That should give us values that we can add using num+. And so on. When you keep working through all of this, then you end up with functions that look like this. Here's numc, idc, plus c, multiply is the same, let c, and lamc. And you see that all of the pieces that we've put here correspond to the same pieces that used to be in our interp function. So where interp of appc, say, has this type case on value of a closure or not a closure, now our appc object performs the same work, type case on the value. And our new interp function that we have for convenience just applies the interp method of the object a, that is, it calls a on the environment. So our interpreter now is one step closer to being object-oriented.